Okay, so what we're looking at today are tree diagrams. And a tree diagram can be used to show all the possible outcomes of an experiment. You can follow a path along the branches of a tree diagram to examine a specific outcome. For example, the tree diagram shows the possible outcomes of spinning the spinner below twice. So the first set of branches is the result of the first spin. So I've got a spinner that I haven't spun yet. When I spin the spinner, I can either get red, blue, green, or yellow. There's one of those four possibilities. If I spin the first time and get red, on my second spin, I can still get red, blue, green, or yellow. If my first spin I get a blue, I can still get red, blue, green, or yellow on the second spin because the two spins are independent. They do not affect each other. So regardless of what I get on the first spin, when I go to spin again, the spinner has no memory of the first result. If I get a green on the first spin, I can get red, blue, green, or yellow on the second spin. And if the first result was a yellow, I can get red, blue, green, or yellow on the second. Then I've got to list all my possible outcomes. If I follow each branch, I could get red on the first spin and red on the second spin. That would be red, red. I could get red on the first spin and blue on the second spin. That would be red, blue, red, green, red, yellow. Those are the four outcomes where I got a red first and then spun a second time. If I get blue first, I could get blue then red, blue then blue, blue then green, and blue then yellow. Those are the four results that all had blue on the first spin. I can get green, red if I follow this branch, green, blue, green, 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 yellow. And if I spin yellow on the first, I can get yellow, red, yellow then blue, yellow then green, yellow, and then yellow. So all together, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are a total of 16 possible outcomes. Another way to figure that would be to ask how many outcomes were there for the first spin and how many possible outcomes were there for the second spin. So I could have had 4 outcomes on the first spin, red, blue, yellow, or green, and there are 4 possible outcomes on the second spin, red, blue, yellow, or green, making a total of 16 possible outcomes. Is the second spin dependent or independent of the first spin? Well, did the first spin in any way impact what I could or couldn't get on the second spin? And the answer is no. The spinner doesn't remember. You could get red, 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 red 4 times in a row. You could get red, green, yellow, blue, and never have a repeat. But the spinner doesn't remember the first result, so it can't possibly impact the second. So they are independent. What is the probability of spinning red, then green? So a red on the first spin, and then a green on the second spin. There is only one outcome that has red first, green second. That means it's a 1 out of 16. What if I just want some combination of red and green? Like red and green, or it could be green and red, and I don't care which one. If it's got to be a combination of reds and greens, it could be this one. It could also be this one. It doesn't say anything about them being in the same order. Back here, the word then told us red had to be first, then green had to be second. This one's just red and green, and there are 2 possible outcomes out of 16, or 1/8 of the outcomes. What if I'm happy with any combinations of reds or greens? So I have to go back up here and say, as long as it's got a red or a green in the outcome, I'm happy. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of the outcomes have a red or a green in them somewhere. So that would be 12 out of 16, or 3/4. The problem probability that I get any reds. So let's say I'm playing Candyland and I know that I have to get a red in order to get to the end. So in my next two, if I can get a red in my next two draws, I know I'm going to win because everybody else is way back stuck in like the very early part of the game. So if I want any reds, then I only want to check off red, 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 blue then red, green then red, yellow then red. That would be 7. 7 out of the possible 16 outcomes in lowest terms. Maybe I'm trying to avoid something in the game and I don't want to land on red for some reason. That would be anything that does not have a red. So 3 there, 3 there, 3 there, that's going to make 9. 9 out of 16. What's the probability I spin and get a color? Well, the only thing on my spinner are colors. So that's going to be certain. So it's going to be 16 out of 16, which is 1. And we can also say that it is certain. Based on that spinner, I am certain that I will get a color. And purple. Well, considering we can't mix colors on a spinner and there's no purples there, it's going to be 0 out of 16. We could also say 0, and it is impossible. So in order for this to work, first I have to create the tree diagram, which is this step. What can I get in the first spin? What can I get in the second spin? These are independent events, so I can get red, blue, green, or yellow in the first spin. I can still get red, blue, green, or yellow in the second spin. And then I have to make my list of outcomes because I can't do any of this probability work down here without having a list of possible outcomes to count up. I want to make sure I've got all my outcomes so I can double check. There were 4 things on the first spin, 4 things on the second spin, which is a total of 16. And I just want to double check that I actually got 16, 4, 4, 4, and 4.